In part 2 of our lesson on equations with inverse trig functions, you will learn how to solve equations involving two different inverse trig functions. Let's look at this first example. We have arc sine of x minus arc cosine of x has to equal pi over 6. So the technique here is first you will want to isolate one of the functions. I like to keep my variables positive, so I think I'll keep the arc sine of x on the left-hand side, and I will go ahead and put the arc cosine of x over on the right-hand side so that it becomes plus arc cosine of x. Now, what will happen next is we are going to substitute for arc cosine of x. Remember that the output of an inverse trig function is an angle. And then we would know that the cosine of that angle, we're calling it theta, has to equal x. That's that inverse relationship that we reviewed in an earlier lesson. If theta is equal to the arc cosine of x, that means that the cosine of theta is equal to x. Now we can draw a picture of that. So we have let's let this be theta. If the cosine is x, we know using SOHCAHTOA that cosine is adjacent over hypotenuse. So we can think of this as x over 1, where the x would be the adjacent side and the 1 would be the hypotenuse. So we can label that on our picture. The x goes here, the 1 goes here. Then we can solve for the y value now, because we know y is going to be the square root of the hypotenuse squared, so 1 squared, minus the adjacent leg squared, x squared. So this equals, when we simplify it, square root 1 minus x squared, and we can label this now on our diagram. So the y value is radical 1 minus x squared. So now our equation becomes arc sine of x is equal to pi over 6 plus theta. Now this is going to be a temporary substitution. Eventually we will have to get back to x because that's what our equation was written in terms of. But substituting momentarily allows us to get rid of one of the trig functions for just a few minutes here. Now we know to undo an arcsine function, we will need to take the sine of both sides. So we will take the sine of the entire left-hand side, which is arcsine x, and that will equal taking the sine of the entire right-hand side, which is pi over 6 plus theta. On the left-hand side here, we know that sine of arcsine of x will become x. On the right-hand side, we can use the sum identity for sine of a plus b. So we know the sum identity tells us to take the sine of the first, so pi over 6, times the cosine of the second, theta, plus the cosine of the first, pi over 6, times the sine of the second, theta. Now let's simplify where we can. Our equation becomes x is equal to, we know that the sine of pi over 6 is 1/2. Now for cosine theta, we can use our picture that we made. We know cosine theta will be adjacent leg divided by hypotenuse, so x divided by 1 is x, plus, now we have to do cosine of pi over 6 is radical 3 over 2, and then we have to take that times the sine of theta, which in our picture will be opposite leg divided by hypotenuse, so that's going to be radical 1 minus x squared. So we are able to combine like terms here. We have a 1x here on the left-hand side, and we have a 1/2 x here on the right-hand side, so we can subtract 1/2 x from both sides. And we see that our equation will become 1/2 x is equal to radical 3 over 2 times radical 1 minus x squared. From here, we can multiply both sides by 2, so our equation becomes x is equal to radical 3 radical 1 minus x squared. Now we can use a technique from our algebra class where we square both sides. So the left-hand side becomes x squared, and the right-hand side becomes 3 times 1 minus x squared. All the radicals disappear. Now, we know when we square both sides that we are going to have to check for extraneous solutions. For now, let's carry on the algebra. We have x squared is equal to 3 minus 3x squared. We add 3x squared to both sides, and now we have 4x squared is equal to 3. Dividing by 4, we get that x squared is equal to 3/4. Using the square roots property, we get that x will be plus or minus the square root of 3/4, which means that x will be plus or minus radical 3 over 2. Now remember, because we squared both sides, we know that means we will have to check in the original equation for extraneous solutions. So let's do our check over here. We know that the original equation was arcsine of x minus arc cosine of x has to equal pi over 6. So let's try our solutions. We have x is equal to radical 3 over 2. So the question we're asking ourselves, does arcsine of radical 3 over 2 minus arc cosine of radical 3 over 2, does that equal pi over 6? Remember, the output of an inverse trig function is an angle. So you are thinking in your mind, what angle has sine theta is radical 3 over 2? And that angle would have to be pi over 3. Then we have to subtract the arc cosine of radical 3 over 2. And so you think of an angle such that cosine theta is radical 3 over 2. Well, that would have to be pi over 6. And we are asking, does that equal pi over 6? We know that pi over 3 is the same thing as 2 pi over 6, and we are subtracting 1 pi over 6. So yes, indeed, that does equal pi over 6. So that is a yes. So this is a solution. Let's check x equals negative radical 3 over 2. We are asking, does arc sine of negative rad 3 over 2 minus arc cosine of negative rad 3 over 2, does that equal pi over 6? Now we know arc sine of negative rad 3 over 2, or remember, you can think of it in your mind as sine inverse of negative root 3 over 2. You're thinking of an angle such that the sine of theta is negative rad 3 over 2. Now you have to think about the range of sine inverse. The range of sine inverse is from negative pi over 2 to positive pi over 2. So the only angle in that range would be negative pi over 3. And we have to subtract the arc cosine of negative root 3 over 2. So we ask ourselves, what angle would it be true that the cosine of theta is negative root 3 over 2, and theta has to live between 0 and pi? Well, the only angle between 0 and pi where the cosine of theta would be negative root 3 over 2 is 5 pi over 6. And so we are trying to discover if subtracting those two equals pi over 6. Well, negative pi over 3 is negative 2 pi over 6 minus 5 pi over 6. Does that equal pi over 6? Negative 2 pi over 6 minus 5 pi over 6 is negative 7 pi over 6, and that definitely does not equal pi over 6. So this is a no, and we have to throw this solution out as extraneous. So the only answer that works in this case is x equals positive rad 3 over 2. In this example, we have to solve cosine inverse of 3/2 x minus tangent inverse of x equals pi. So remember, first thing we did was to isolate a trig function. Since the cosine inverse is positive, I think I will leave it alone on the left-hand side. So we have cosine inverse of 3/2 x is equal to pi plus tangent inverse of x. Now the next thing we did was substitute for the inverse function. So we are going to momentarily call this theta, and we know if theta equals the tangent inverse of x, then that means that the tangent of theta has to equal x. We can draw a picture of theta. And we know that using SOHCAHTOA, tangent is opposite leg over adjacent leg, so we can think of this as x over 1, and this would be opposite leg over adjacent leg. So when we mark our picture, we would mark this leg with an x and this leg with a 1. We know that the hypotenuse, or r if we want to call it, we know that r will be the square root of x squared plus 1, so we can label that on our picture. Now we can rewrite our equation to be cosine inverse of 3/2 x is equal to pi plus theta, because remember, we're going to momentarily substitute theta for that tangent inverse of x. Now to get at the x inside the cosine inverse function, we know that we will have to take the cosine of both sides. So we will take the cosine of the cosine inverse of 3/2 x equals the cosine of the entire right side, which is pi plus theta. Now on the left-hand side, cosine of cosine inverse undoes each other, and we are left with 3/2 x. On the right-hand side, we can use the sum identity for cosine. So we know that will be cosine of the first, pi, times cosine of the second, theta, minus sine of the first, pi, times sine of the second, theta. The left-hand side stays the same, so 3/2 x equals. Now we're going to fill in all four of these values. We know that the cosine of pi is -1. The cosine of theta is going to come from our picture, and it would be adjacent over hypotenuse, so we get 1 divided by radical x squared plus 1 minus The sine of pi we know is 0, and the sine of theta comes from our picture, opposite leg divided by hypotenuse, so x divided by radical x squared plus 1. Of course, this 0 will wipe out this whole term, so now we have 3/2 x is equal to negative 1 over radical x squared plus 1. Now we can square both sides. And of course, we know that means that we are going to have to check for extraneous. Now the left-hand side, once we square it, is going to become 9 over 4 x squared. The right-hand side, when we square a negative, it becomes a positive. The numerator will be 1, and the denominator is going to be x squared plus 1. To solve this, we can cross multiply, so this 4 will go up on the right-hand side, and this x squared plus 1 will go up to the left-hand side, so we have 9x squared times x squared plus 1. This becomes 9x to the 4th plus 9x squared is equal to 4. So we need to get everybody on one side, so this 4 will subtract over to the left-hand side. So now we have 9x to the 4th plus 9x squared minus 4 is equal to 0. To factor this, we need to think of the factors of 9, which would be 1 and 9, or 3 and 3. And we need the factors of 4, which would be 1 and 4, or 2 and 2. And we are searching for the product pairs that will give us a positive 9. Now remember that one of our products will be positive and one will be negative because we need that negative 4 over there. So looking through this list, we can see that if we took 3 times 4 and let that be a positive 12, then we could do 3 times 1 and let that be a negative 3. Positive 12 minus 3 would give us that 9 that we need. Now this gives us the first coefficient in each binomial. So it's going to be 3x squared and 3x squared. We know that this first 3 needs to be tied to a 1, and we need to get minus 3 out of it. So we're going to take 3 and make this a minus 1. The second 3 has to be tied to a 4, and that has to give us a positive 12. So we will put a plus 4 right there. Next, we will apply the zero product property. And we have that 3x squared plus 4 has to equal 0, or 3x squared minus 1 has to equal 0. Let's solve this first one. We would subtract 4 from both sides. we get 3x squared has to equal -4. Well, right here, we know we can stop because a squared number can never be negative in the real number system. So this is a no solution. That's kind of nice. Cut down on the amount of work we have to do. So let's turn our attention over here. We get 3x squared has to equal 1, which means x squared is 1/3, which by the square roots property tells us that x is going to be plus or minus the square root of 1/3, which is plus or minus 1 over radical 3. And we can rationalize that, rad 3 over rad 3. So now we have that x is plus or minus radical 3 over 3. And now these values have to be checked. So now we come up here and we check for extraneous solutions. We know we have to use the original equation, which is cosine inverse of 3/2 x minus tangent inverse of x has to equal pi. So let's try our first solution, x equals radical 3 over 3, and plug that in. So we have to do cosine inverse of 3/2 times radical 3 over 3 minus the tangent inverse of radical 3 over 3. We're asking if that equals pi. Well, we notice that the 3 here will cancel the 3 here. So what we're really doing is the cosine inverse of radical 3 over 2. So if we're doing the cosine inverse of radical 3 over 2, you're thinking of an angle such that cosine theta equals radical 3 over 2, and theta must be between 0 and pi. Well, the only angle for which that is true is pi over 6 minus tangent inverse of radical 3 over 3. So you are thinking of an angle such that the tangent of theta is radical 3 over 3, and theta must be between negative pi over 2 and positive pi over 2. And the only angle for which that is true is pi over 6. And we're asking, does that equal pi? Well, the left-hand side, pi over 6 minus pi over 6 is 0, and that definitely does not equal pi. So this is a no, and that is an extraneous solution. We have to throw it out. So next, we will try x equals negative root 3 over 3 and see if that one works. We have the cosine inverse of 3 over 2 times negative radical 3 over 3 minus the tangent inverse of negative radical 3 over 3. Does that equal pi? So let's simplify here. These 3's are going to cancel again. And what's really happening is we're doing the cosine inverse of negative radical 3 over 2 minus the tangent inverse of negative root 3 over 3, and we're seeing if that equals pi. So here you have to think of an angle such that the cosine of theta equals negative radical 3 over 2, and theta must be between 0 and pi. Now the only angle for which that is true is 5 pi over 6 minus, here we have to do tangent inverse of negative radical 3 over 3. So now you have to think of an angle such that the tangent of theta is equal to negative root 3 over 3, and theta must live between negative pi over 2 and positive pi over 2. The only angle for which that is true is negative pi over 6. And we're asking if that will equal pi. Well, we have 5 pi over 6 plus 1 pi over 6. We get 6 pi over 6, which definitely does equal pi. So that's a yes. So the only solution to our equation is that x is equal to negative radical 3 over 3.